going to start with the new chapter of, that is, surface chemistry. So the topics which we have to cover in this unit are introduction, absorption, then adsorption versus absorption, mechanism of adsorption, types of adsorption, then adsorption isotherms, what are the applications of adsorption, catalysis, colloids and emulsions. So these are the topics which we have to cover in this unit. The first topic is absorption. Now what is absorption? You must have studied about this in your junior classes as well. See, we have, just see, look at the picture. In first picture you can see we have a glass filled with water and a sponge. Now if we simply put sponge inside the glass of water, what happens? The sponge will absorb all the water and now the glass is empty and you can see the small sponge is full of water. Now if you will try to press the sponge with your hands, you will see that all the water will shrink out from the sponge. So what is absorption? In one substance, another substance, water enters and distributes uniformly throughout the bulk. So here in the sponge, water actually it gets distributed uniformly throughout the bulk. Remember one thing, absorption is a bulk phenomenon. Next we have, again, can you see this picture? So sponge molecules, water molecules are also present here. Can you see the water molecules? They are also present on the surface as well as inside the sponge. So it is a phenomena in which one substance enters into another substance and gets uniformly distributed throughout the bulk of another solution, and this is called as absorption. Next we have, what are the examples of absorption? See, very day-to-day life examples. You might be feeling hungry after seeing these pictures. See, very common example, when we whether you drink tea or coffee or milk, whenever you dip a rusk or even a biscuit in a tea or rusk or in a tea or milk or coffee, what happens? See what happens. The layer, the tea, the rusk actually absorbs that tea, right? The particles of tea are not only present on the surface, but it's actually present inside the rusk also, right? So what happens? This is a phenomenon of absorption. It is a bulk phenomena. That is why when we dip, sometimes what happens? When we dip, what happens? The biscuit or the rusk, it gets softer. And what happens if you dip for longer period of time? What happens? It actually breaks and get inside the cup of tea. It happens, right? Many times. So this is absorption. Another example is gulab jamun, a very famous example and a tastier one. What happens in case of gulab jamun? Like we know how gulab jamun are prepared. These are prepared just by frying, yes, deep frying. But when we keep gulab jamuns inside a sugar syrup, what happens? The gulab jamuns, they actually absorb all the sugar syrup. Now the sugar syrup is present not only on the surface of gulab jamun but also inside the bulk of gulab jamun. That is why it tastes sweet, right? So now you have to understand these two terms. Now what is adsorbate and what is adsorbent? The substance which is being adsorbed, the substance which is being adsorbed is called adsorbent, and the substance which adsorbs is called adsorbate. Like rusk is actually adsorbate because on the surface the particles gets attached, and here this tea is adsorbent, right? I know this is absorption, but I'm just giving you an introduction about adsorption. Now what is adsorption? Like suppose when we try to write on a blackboard with the help of a chalk, what happens? The blackboard is black in color. Now when we write with the help of chalk and when we rub the chalk, what happens? Still you will see white particles present, right? So this is an example of adsorption, and these chalk particles will not get deeper inside the chalk blackboard. Therefore this is actually adsorption. It is a phenomena in which the one substance accumulates on the surface of another substance in higher concentration. What is this? This is the phenomena in which one substance accumulates on the surface of another substance in higher concentration. So this is actually a surface phenomena. This is actually a surface phenomena because the particles are getting accumulated only on the surface. Next we have examples, silica gel. Like whenever you go to market and whenever you purchase water bottles, laptop bags, or they give you one. When you open the seal, what happens? You'll find one silica gel packets. Now why they are present inside the water bottles? Because to adsorb all the moisture present inside the bottle. And it's advisable that whenever you are we generally use water bottles, generally use Milton water bottles, generally we use in summer season, right? Yes, we do use in winters, but maximum times we use in summer. So they actually there's a note present in those water bottles is they actually in which it's written that please keep this packet inside the bottle while storing. Why? Because I agree that whenever we are storing a water bottle, we firstly dry the water bottle and then we store it, but still there are some water vapors present in air, humidity is present. So the role of silica gel is to adsorb all the water vapors. Second example, chalk and board, we have done it. The water vapor on the surface of window, a very famous example of our day-to-day life. Especially in winters, what happens? We observe that fog, water vapor particles, liquid particles gets adsorbed on the surface of window. So this is also an example of adsorption. See, adsorption. Now this is bulk. This is the surface is adsorbent, and on the surface of adsorbent has come. So on the surface of adsorbent has come. So this is actually an example of surface, and that is why the name of the chapter is surface chemistry, because we are dealing with the surface phenomena, right? Now you must be thinking, what is the reason behind this adsorption? Why this adsorption is taking place? And why I am teaching you all this? See, what happens here is, suppose this is, let's take a example of, see, let's take an example of, let's take a beaker. Yes, and we know that, and suppose this is water molecules are present inside this beaker. Now the molecules which are inside this beaker in the inner surface, they'll have balanced forces of attraction, right? Because we know that all the molecules are present here, everywhere, but the molecules which are present on the surface, they will observe unbalanced forces of attraction. They will feel unbalanced forces of attraction, right? Now, due to which there are some particles or molecules present on the surface, there are some molecules present in the air. So because these particles, they are observing unbalanced forces, so they will attract these molecules present in the air towards itself to get themselves balanced. So now earlier they were unstable, but now the surface molecules have become stable after adsorption. So we know that when an unstable thing is getting converted into stable, what happens to energy? Enthalpy is decreasing. It's an exothermic process because it has become stable. So the energy becomes lesser. So delta H is negative, or you can say this is an exothermic process. In other words, we can say this process is exothermic, right? First point. Now second point. Now initially there were so many molecules present in air, but after adsorption, what happens to the molecules? They decreases. So can we say that delta S, entropy also decreases? So let us on, if these two terms decreases, now what happens? We know that delta G is equals to delta H minus T delta S. Delta G is equals to delta H minus, since this is negative and this will become positive now. For a reaction to be spontaneous, delta H should be greater than T delta S. Then only we'll get delta G in negative value, right? So this is the reason for adsorption. I hope it's clear to you. Now next we have, see, adsorption versus absorption. Now adsorption, as I told you, it's a surface phenomena, right? The molecules are accumulated only on the surface. Adsorption is a surface phenomena, whereas in case of absorption, what happens? It's a bulk phenomena, because you can see the particles are present on the surface as well as they are going inside into the bulk of the solution. Is it clear? Now next we have, let us quickly read out the differences between absorption and adsorption. First, absorption is a bulk phenomena. Yes, we have done it. Adsorption is a surface phenomena. Absorption, it's neither endothermic nor exothermic, but adsorption is an exothermic process. Very obvious, like we have just discussed, delta H is negative. But let's discuss about absorption. Like if we have water and I am adding sponge into the water, tell me, this is a very physical process. So do you think any amount of energy will release or any amount of energy will get absorbed? Whenever you are adding sponge into water, will the temperature of the water will increase or decrease? Nothing happens to the temperature. So therefore, it's neither endothermic nor exothermic in nature. Now, rate of absorption, it has uniform rate because it's a bulk phenomena. Like similar example I'm taking, if I'm adding sponge into the water, the sponge, the molecules will get inside the molecules of water gets inside the molecules of sponge uniformly throughout, right? But what happens in case of adsorption is rapid in the beginning due to the availability of the surface area, because we know adsorption is a surface phenomena. So initially when there were no molecules present on the surface, so initially the rate is very high. But once the surface gets accumulated by the molecules, now what happens? Can further molecules can come? No, they cannot enter. So what happens? Falls down later since the surface is occupied. Absorption, it's independent of the surface area because it's a bulk phenomena, right? The molecules have to enter inside the bulk also. But here it depends on the surface area, right? Because the molecules have to just settle down on the surface. Uniform distribution, the adsorbate gets uniformly distributed, but here non-uniform adsorption, that is only on the surface. Yes, we know that the particles of adsorbate gets adsorbed only on the surface of adsorbent. I hope this is very clear to you. Very simple. Next we have, what is the combining process of absorption and adsorption? Better, this is called as sorption. When absorption and adsorption, these two processes, they are occurring simultaneously, it's called as sorption. For example, a very famous example, for example, like you must have seen your mother going to dye, get her dyeing her cloth. Your mother going for getting her cloth dyed. So what happens? What that shopkeeper does is he actually adds that cloth inside the dye, the solution of dye. Now what happens? The dye molecules not only gets absorbed on the surface, but also they get into the bulk of the solution. That is why, suppose we had a dupatta of white color, and after dyeing, what happens? If you want blue color, you can blue color on the dupatta. You can green color, red color, orange color. It depends on your demand. So this dyeing of cloths, it's an example of sorption. Now there's one more thing that you have to study here is, one is desorption. Desorption. Now what is this desorption? See, desorption is removal of adsorbed particles. What is adsorption? Means the particles are getting adsorbed on the surface. But here desorption is removal of adsorbed particles. Yes or no? Clear? Now next we have, what are the types of adsorption that we have to study? See, it depends on the nature of the forces between adsorbate and adsorbent. For example, we have two types of forces that we have to study. If the forces can be weak and the forces can be strong also. So for weak forces, when weak forces such as van der Waals forces exist, then the type of adsorption is called as physiosorption. We call it physiosorption. But when the forces are strong, we call it, means chemical bonds are present. When chemical bonds are present, we call it chemisorption. Any doubt? Next we have, now before moving to this, now let us discuss about heat of adsorption. See, it is the amount of heat evolved when one mole of an adsorbate, that is gas or liquid, is adsorbed on the surface of adsorbent. Like suppose this is adsorbent. Now if 1 mole of gas is getting adsorbed on the surface of adsorbent, the amount of heat, this is 1 mole. When 1 mole gets accumulated on the surface, the amount of heat evolved will be heat of adsorption. This is actually heat of adsorption. Clear? Now next is, let us try to differentiate what is the difference between physiosorption and chemisorption. See, the difference is the molecules are attracted to the surface simply by van der Waals forces. In physiosorption, what happens? The molecules are attracted to the surface by van der Waals forces, like I told you, weak forces. But here, the molecules are held together to the surface by chemical bonds forming surface compounds. Means molecules actually form surface compounds. Since van der Waals forces, so it's relatively weak. But here, chemical bonds, so it is relatively strong in nature. The heat of adsorption is low and lies in the range of, please remember this value, 20 to 40 kilojoule per mole. But here it's high, and the value is 40 to 200 kilojoule per mole. Physiosorption, because weak forces are there, so it is reversible, but it is irreversible. Because what is physiosorption? Simply adsorption and desorption, right? I have told you. Yes, it involves the formation of multi-layer but it involves the formation of monolayer of adsorbed particles. I will discuss about this in further classes. Like suppose when we dip a wood in a liquid, what happens? There's a formation of multi-layer. This is an example of physiosorption, but here the only formation of monolayer takes place. Next we have this physiosorption. It's not specific in nature, but it is highly specific. We'll get to know more about it when we go through the examples. It occurs appreciably at low temperatures, and as we increase the temperature, what happens? The extent of absorption decreases. But here it occurs at all the temperatures, but chemisorption, the extent actually increases with increase in temperature. So this is physiosorption, like just on the surface. But here chemisorption, as it's highly specific in nature, so we have the binding sites, and on the binding sites the adsorbate particles get adsorbed. Now let's talk about examples. But before going to the examples, I would like to discuss this point, 7th point, in detail. See, 7th point. In case of physiosorption, what happens is, Like this is suppose uh, extent of adsorption. This is extent of adsorption, and it's x by m. We'll study it later. X by m, extent of adsorption versus temperature. As I've told you, in case of physiosorption, what happens? It decreases. So the graph will be like this. The graph will be somewhat like this in case of physiosorption, right? And what happens in case of chemisorption? This. And in case of chemisorption, what happens is we'll get a, like again, extent of adsorption versus temperature. Initially, with rising temperature, chemisorption increases, but after reaching to a certain point, it decreases. This is the graph for chemisorption. After a certain point, it starts decreasing. Now, let us discuss some examples quickly. The examples of physiosorption and chemisorption. See, what are the examples? Like we know that we have charcoal that's made from carbon. Now this charcoal is used to adsorb various gases. In nature, like for purifying gases, we use charcoal. Yes, this is example of physiosorption. And silica gel, chalk plus powder, these are all examples of physiosorption. Now let's talk about chemisorption. Like we know, like whenever we purchase gold or silver ornaments, right? Whenever you go to market and purchase silver and gold ornaments, initially they are new, right? But what happens after certain time, after few months or years, what happens? Their shine actually gets lesser with time. So what happens? Due to the adsorption of oxygen on their surface. This is oxidation. Next we have, like we know, a very famous catalyst you must have studied in class 11th also. On the surface of palladium, we get H2 molecules. We get the adsorption of H2 molecules on the surface of palladium, right? Last we have, suppose this is graphite. Now what happens here is, this graphite means carbon. Now we have carbon. This carbon reacts with oxygen molecules present on the surface and it will form now. Now on the surface, we want to be having carbon particles. We'll be having CO molecules on the surface. So this is what happens in case of chemisorption. We get a new product. I hope this much is clear to you.